We're going to work on the timing. Cut. Okay. All right. Same negative 9 to 9. I think, Gael, you just noticed that this is actually telling you this is the graph of the derivative. So this is something new. So far, we've only looked at the graph of the original. This is the first time we actually are given the graph of the derivative. So it says, determine the values of x, if any, at which the function f has a critical value, also critical point, on this interval. Do you guys remember how to find critical points? It's where the
y is 0.
For what? Y0 for what? You're right, but for what? For the derivative. You can also say it like that, the tangent line slope is 0, but it's where it's 0, and I mentioned yesterday, or where the derivative is undefined. Are we having that yet? We haven't had that yet. So if a critical point is where the derivative is equal to 0, I just need to find, Andre said, where the y values are 0. Another way to say that is look for the x-intercepts. So where does this graph, since this is the derivative, where does this graph touch or cross the x-axis? You ready?
5, 0, 3.
So I heard negative 8, negative 5, 0, and 3. And that's it. You're done.
Oh, okay.
That's it?
Yep. So when you do delta math, remember to click the add a solution and add all 4 of them.
That's so easy.
Great. Everybody good on number 1? Let's do number 2. Number 2, same start process here. Notice what's the graph? It says f prime, so this is the derivative. It says, where does the original function, so f, where's the original function, have a relative maximum? So here's what I like to write. So if f of x has a relative maximum, and you're going to literally see me do this, right? Did this in high school, did it in college. Relative maximum means we are increasing and changing to decreasing. So I write f of x goes from increasing, I forgot who was second, but whoever was second. Is that Robert? Okay, good call. To decreasing. Georgie, you had a question? Okay. So do you guys see it? I know I put INC, that's increasing, DEC, decreasing. Go ahead.
So would be the point right before the 9.
You ready for it? Let me write this, okay? So if that's what I want to see from my original function, right? Based on our objectives for this whole week, I write, so what would that mean is happening with our derivative? The derivative goes from positive to negative. So Gael, you're right. Because they're giving us the graph of the derivative, I need to find where does it go from a y value that's above the x-axis to y values that are below the x-axis. Okay, you ready? All right. So where do I go from y values above to below? Here's y values above. Here's y values below. So what is that x value? Just negative 3 though, right? So Bernadette, I'm going to actually mention this because you said negative 5. That is a relative or local maximum for the derivative, right? So in this case, we're using the derivative function that's given here to talk about the original. So that's a good thought, but not for this question. If it had said the graph of f, it would be x equals negative 5. Does that happen anywhere else to go from positive to negative? Here I'm going from negative to positive, so this would be a relative minimum at x equals 1. What's happening here, though? Do I get to the other side? No. So there's only one answer at x equals negative 3.
Wait, would you do like the double thing? Would you get the derivative of 1?
Oh my gosh. Mm-hmm. Yes. And do you think that's coming tomorrow?
Yes.
She's asking about the second derivative. We haven't even talked about the second derivative test. That's coming tomorrow. All right, we got to talk about concavity and inflection points, which is not cavities, like concavity. Okay. What'd you say? You know, I can go back and listen and then figure out what you said.
Oh, were you recording?
I am. forever. Go to number 3. We're going fast enough. Let's do number 3 and 4. Okay. It says determine all the intervals on F where it's increasing. So if F is increasing, so f of x is increasing, what does that tell us about our derivative? F prime of x is, I thought I heard someone say, is positive. So I just need to figure out where on this entire curve, since this is the derivative function, where are the positive values? So I'm looking at this, right? Here's my x-axis, just looking for the intervals where this function is above the x-axis. So if I just draw it with my pen, that's here, that's here, that's here, and that's there. You guys see all that? So now I just write down those intervals in parentheses connected by the u. So -9 to -8. I'm not going to get into that right now. It just means union. We're going to use these symbols in probability with stats as well.
Didn't we do that in algebra?
I don't know.
I remember, but
We did. Yeah, we did. Wait, what's it?
Did I mess one up? Because this right here, these values are positive. So from between -9 and -8, if I looked at the original function, it would be increasing. All right. It's about to not be, right? At -8, it switches to decreasing. You okay, guys?
So if it was asking,
Where is it decreasing?
yeah.
It would be -8 to -5, -2 to 1, 4 to 8. The other. All the y values have to be negative. Let's do one more. The last one. Where do we have a local minimum? All right, so local minimum, remember, if you need to do what I'm doing, right? Local minimum means I am decreasing to increasing. So I'm going to write down f of x goes from decreasing to increasing. All right, now what does that tell me about my first derivative test? What's happening with my derivative then?
From negative to positive.
I love it. You guys are doing great. Okay, so I need to figure out where on my graph do I have a y value that's going from negative to become positive. All right, well, first off, I need to have a negative y value. So it looks like here, just past -1 is where I start to get negative, right? And then between this value, right? So these are negative, these are positive. What is that x value where I'm changing from negative values to positive y values? 4. Do I have any others where I'm going from negative to positive? So the only answer is x equals